Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by the students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by a very special crew. We have a whole bunch of folks joining in. In fact, tonight is our 600th episode. So, in no particular order, we have Sunna Withers, Paul Mackin, Julie Tomei, Paul Delaney, and Ryan Marciniak, who may be joining us for just a few moments. This special episode is, of course, one of our regular York Universe broadcasts, live every Monday night, 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT, if that's more your speed. We are, of course, running in a podcast mode, but we do broadcast live on YouTube at York U Observatory in concert with our online public viewing program run by the observatory team. Those are the folks who are in charge of the wonderful visuals that you will see over on YouTube if you join the live broadcast. To navigate to the live show or to find out more about our observatory, check out our website at yorku.ca/science/observatory and follow the links to online public viewing or OPV. You can also click on any YouTube link on our website, and it's pretty much going to take you straight to the regular York U Observatory channel. If you have any questions or comments about past shows or suggestions for future topics, you can always email us at observe@yorku.ca, and you can find us over on social media at Instagram at York U Observatory, Facebook at Allan I. Carswell Obs, and PixelFed at Allan I. Carswell Observatory. All of our programs, including this one, are free, but if you'd like to make a donation to help support the observatory and pay our wonderful students, our work study students, you can see the donation button over on yorku.ca/science/observatory. We are, of course, looking at the weather at the moment and carefully guiding the skies. We have a wonderful show lined up for tonight, and we do have people live on site at the Allan I. Carswell Observatory right now to help us with our 600th episode. So just as a little reminder, the 600th episode spectacular is a Saturn deep dive. So we're going to do a little bit of exploration about our mysterious distant cousin and its so-called disappearing rings. Do they really disappear? Maybe just for us. So we have a wonderful show tonight. And of course, we do have folks live on site. So we're going to try to connect over to them now if we can get them to come through. So we're calling over to the 1 meter telescope. Sana, are you there?
Hi, yes, I'm here. Can you hear me?
We can hear you wonderfully. So live from the 1 meter telescope on campus. We're joined by Sunna Withers, and of course we have a little bit of a problem because the weather tonight has been not so great. Is it still cloudy over there, Sunna?
Yes, it's still very cloudy.
Oh dear.
We got a little bit of observing in at the beginning of the night, but unfortunately had to close down because there were way too many clouds and we can't even see anything. But instead of showing some live views, we can show a couple live views of the telescopes themselves. So we've got the 60 centimeter telescope and the 1 meter telescope over here, both viewed through our security cameras. And one of the really awesome things about these security cameras is that we can actually hear what's going on in the domes themselves. So with our 1 meter computer over here, if we bring up the plane wave interface, where is that?
Wonderful. Yes, the control
Yes.
interface for the telescope. And of course, we probably have the telescope and the dome synced up already so that they follow each other across the sky.
Yes, we do. So this is the plane wave interface. We can kind of move around here on this virtual sky map, zoom all the way in. It shows us where a whole bunch of different objects in the sky are right now. Saturn will not be up here because it's actually below the horizon at the moment. But we could go to another very interesting planet, Jupiter. So if I click on Jupiter and hit go to, we can actually watch the 1 meter as it slews over to Jupiter.
Excellent. And for those of us who are just joining on the podcast, listen carefully because the dome, this will make a sound as it tries to follow. All right, hopefully that's coming through to everyone okay. That is the sound of tons of galvanum coated steel rotating around the 1 meter telescope as it quickly arrives at its destination.
The 1 meter
The
is very
creaking,
fast.
oh yeah, it's very fast, and the creaky noises are supposed to be there, don't worry. Um, but yes, if it was clear, we would be able to open up the domes as well and show live viewing. But for tonight, at least we can share some of the sounds of the telescope with our radio podcast crew.
And we can show quickly a couple images that we did get earlier in the night of the moon. We had maybe about an hour or so of sunrise. We were able to snap a couple images of what's now the crescent moon. Here's one of those. And also a second image with Mare Crisium right over here, which is one of the awesome craters on the moon.
Yes, this was the one we were talking about earlier. If you, Mare Crisium is visible on the moon if you do have clear skies tonight, and this is the one that looks, we think, a little bit like a very happy cat,
Yes.
or as we were calling it, I believe, smiley cat crater.
Yes. Definitely does look like a smiley cat over here.
And the moon is a 22% phase at the moment, so it is a nice crescent. Um, But unfortunately, the clouds are blocking its beautiful view from Toronto during the live broadcast, which is a little
Yes.
unfortunate.
One other picture I can show is a fairly recent picture taken at the observatory in the theme of Saturn's disappearing rings. This was a couple months ago when the rings are starting to get a little bit thinner. They're not exactly edge on and fully disappeared like they will be soon, but they're kind of starting to get towards that phase. So on top of Saturn here, we also have its moons Tethys, Dione, and Rhea over here. So a nice little picture from the 1 meter of both Saturn and its moons in the same picture.
That's amazing. As of course, we'll go ahead and bring in I think some of our guests who are waiting in the wings here, in no particular order. Paul Delaney, do you want to come in and say anything about the imaging of the Saturn's rings and what you're most excited about watching the rings appear to disappear?
Good evening, Elena, and thanks very much for the image, Sunner. It really brings back wonderful memories. I mean, Saturn is always a wonderful object to look at. The ring system makes it just, iconic. But when the rings go edge on, which they do, I think, about every 15 years, then Saturn becomes something of a regular planet. And it looks naked, it looks odd. And I remember the first time that I saw Saturn in its edge on phase, and that was all the way back, I'm dating myself here, all the way back to the summer of 79. And that was just mind blowing to me. I mean, it sounds silly to have a planet go edge on and for it to be mind blowing, but when you're always expecting to see Saturn with its spectacular ring system, to not have it there at all, always memorable, always memorable.
Absolutely. And of course, as our first person that we're picking on, because this is the 600th episode, I actually have put in a couple Saturn riddles that I thought would be fun for folks. So I'm going to ask you the first one, Paul, and
Okay.
it is Saturn related. So it's not Jupiter's Great Red Spot. This storm rotates quite a lot. Its patterns include speckles and dots, but its unusual shape is found at Saturn's top.
I'm
Do you
gonna
know what
guess
it is?
I'm guessing we're talking about Saturn's hexagon, first found, if memory serves, by the Cassini space probe.
Yes, indeed. Of course, this is one that we would have a real trouble viewing from Earth.
That's an
um,
understatement.
because it is up at Saturn's top or bottom, depending on, I guess, which angle you're approaching from. But it's a hexagonal cloud pattern, which is just such an interesting feature for clouds to have. You don't generally think of clouds as being geometrically regular, but apparently they have managed to reproduce geometrically regular features in some fluid rotations here on Earth. So this as far as I can tell, we think it's some sort of standing wave pattern, but it's just really interesting. And there's so much about Saturn that we still don't completely understand.
It's a big planet. There's lots and lots of atmosphere there. There's terrific rotation that is happening. Everything about the Saturn system I find quite remarkable. The hexagon is just one aspect of it. Every 30 odd years, there is this wonderful storm system that comes across the equatorial region. The ring system itself, Enceladus, Titan, two of the big satellites, or at least two of the notable satellites that are orbiting around Saturn. I think it's over 100 of them these days. I mean, it's a stunning number. Yep, the Saturn system is fabulous. I look forward very much to Dragonfly and its arrival at Titan sometime in the next decade.
Oh, absolutely. As I say, Saturn might be full of hot air, but we still love it. There's just so much to go there. And I mean, every time we turn around, it seems like a new moon has been discovered or something like that.
Quite correct. As I said, over 100. And again, I'll date myself. When I was in elementary school back in Australia, they always had a little bit of a table of the planets in the solar system and how many satellites were observed orbiting around them. The first time I can recall that table, Saturn had 9 satellites. Count them, 9 satellites. Jupiter had 12. And now, of course, as I said, both of them are well over 100. So times have changed since I went to school, it seems.
Yes, it's one of the great things in astronomy is just there's always something to look forward to. All right, so we've gone a little bit into some of Saturn's rings, and we have a little bit of special history as well. Now we're going to go from Paul to Paul. So, Paul Mackin, you've crafted a lovely little history fact for Saturn today. Would you like to go ahead and tell us about what you found for Saturn's space history? If we can get him.
Sure, and this is actually kind of an amazing one, actually. Can you hear me?
Yes, go ahead.
Hello? Okay, you can hear me. Oh, good. Have you got me or not?
Yes, yes. We just have
I
a
think we've got
slight
a lot
delay,
of
I
people
think.
on tonight. Okay. Okay, all right. So this month in Saturn space history, on March 25th, 1655, Christian Huygens discovered Saturn's moons Titan. And this was only 45 years after Galileo discovered a telescope to used a telescope to discover Jupiter's 4 largest moons. And that served as a bit of an inspiration for him. And so, working with his brother, they built a telescope, and turned it to the next planet out. Uh, and because of his position in the Saturnian system with respect to the other moons that were sort of discovered, it was originally designated as Saturn 6, but the name Titan was attributed to John Herschel, the son of William Herschel, who also discovered 2 other moons of Saturn, Mimas and Enceladus, as well as the very famous planet Georgium Sidus, or George's star, named after King George III, which now has the rather unfortunate name Uranus. But Titan, we landed a spacecraft on Titan, named after Huygens, the Huygens probe, and have taken radar images of much of the surface. Titan is the second largest moon in the solar system, and the only one with a thick atmosphere and a hydrological cycle of sorts. Titan has rivers, lakes, and probably rain. Still, the liquid itself is not water, but it is methane. And because Titan is so large and bright, if you look at Saturn now with its rings hidden, as Professor Paul said earlier, it's kind of an ordinary planet. You'll notice Titan is a bright star nearby that moves with respect to the planet every day. But with no rings visible, Saturn looks like a smaller version of Jupiter with only one bright moon as opposed to 4, and a less impressive band of atmosphere, less impressive set of atmospheric bands. But that actually gives Titan some extra well-deserved attention.
Absolutely. And of course, as you say, without the rings there, you mentioned noticing Titan, and of course, noticing moons like Titan and other things is actually a lot easier when the rings are not blocking our view. So getting a what we call this ring plane crossing, this is where the ring is aligned itself so that it's in line with our view of the Saturn and appears to disappear. Well, I believe there's been about 13 moons discovered so far during ring plane crossings, and every time it happens now, everyone gets out their telescopes and quickly starts looking to see if they can find any more rings or any more features they maybe weren't able to find before. I think it was back in 1966, Saturn's E ring was spotted for the first time during a ring plane crossing. That's the outermost of the planet's seven rings, so it's alphabetic from inner to outer, and these lovely, beautiful rings are a little bit hard to see from Earth because we don't get the best view. And 1966, they saw the E ring for actually the very first time, despite it being viewed many years before that. So the 2025 crossing that's happening now, we're not actually getting the best view. I will just say is Saturn is very close to the sun right now. So we saw the rings get very, very thin, and then the weather in Toronto got absolutely awful. And as the rings are um, basically coming into that very nice thin alignment, Saturn is so close to the sun that we're not going to be able to point our telescope at it. So we'll have to wait until it comes back out the other side of the sun, unfortunately. We'll, for another better chance, we'll get another time in 2038 and 39. And I think that it said that there would be 3 ring plane crossings in 2038 and 39. So I'm looking forward to that one really myself. Um, Julie, what do you think? Oh, sorry, Paul. Go ahead.
Well, I was just going to comment on the fact that the rings per se, as Paul indicated, have been visible since the earliest days of telescopic observation. But it wasn't really until our robotic probes, the Voyager spacecraft, swung by very close that revealed that the ring system really was made up of actually hundreds of little ringlets instead of sort of 4 or 5 fairly broad rings like sort of hula hoops, so as to speak. Really, they break down into hundreds of little ringlets. And we had to wait all the way through to like the late 1970s before we got that little insight into the Saturnian ring system. So they kept their secret for well over 400, well, not quite 400 years, but close enough to 400 years.
Yeah, and I actually got one of the Internet Archive has some amazing old books on astronomy, and I forget exactly how far back this one goes, but I saw one of the best figures I've ever seen for Saturn, and it was an old debate by astronomers in the first age of telescopes, and they were trying to figure out what Saturn was because they didn't have the telescopic resolution to actually tell that it was rings. And so there was all these different descriptions for what it could be. Could it be like a toroid? Could it be that the planet was just really, really squished for some reason? It's just this really squished top shape and it's the whole planet. Could it be two big moons on either side? Rather than it being rings, it would just be one moon on one side and one moon on the other side and Saturn in the middle, and it just looks like rings because it's blurred together. And there were all these great theories for what the possible shape could be and debate amongst astronomers writing back and forth to each other that actually I think it's this other shape. And of course one of them did propose rings, and eventually that was the model that won out due to additional improvements in technology and better evidence. But it's just been it's always been a really interesting place to explore.
Certainly is. And, if you go all the way back to Galileo's observations, again, as Paul indicated, back there in 1610, I think you'll find that one of the entries in Galileo's observing diary, as he looked at Saturn, because of course it was bright and high in the sky, and so he had a look at it,
Hmm.
he referred to the appendages on either side of Saturn's as their ears. I mean, I don't think he really
Yes.
believed that they were ears, but that was what it looked like to him, a planet head with a couple of ears. So, yeah, interesting unfolding the mystery of Saturn from its earliest observational days.
And just like so many other solar system mysteries and beyond, the more we find out, the more there is still to know. It is a rare destination, Saturn, I will say. We've had, of course, the Cassini mission orbiting hundreds and hundreds of times over many years, but really before Cassini, it was just Pioneer, Voyager 1 and 2, and there's still just so much we could do. But anyways, that's for future missions that are that are still on in progress. All right, so let's go ahead and get to our next fun history area. We've got a bunch of different things to go for, and actually I realized that Paul Mackin, I did have a riddle for you as well, if you're willing to take it on.
Okay, I'm terrible at these sort of things, but I'll give it a go.
Well, this is just a fun one, so I think you'll get it. When looking at all the planets, this is the second largest one. It has rings made of ice, dust, and rocks, and is sixth one from the sun.
Oh, that's a tough one. Like I said, I'm really bad at these things, but I'd kind of guess it might be our theme planet for today, Saturn.
It is. It is. And of course, I just get an excuse to make things rhyme. And and of course, we do have more fun facts to discuss. This planet is something I'm sure we could all spend hours and hours talking about. But I saw that we have a lovely item from Julie Tomei, and this is again, I think, relating to some of the stuff we talked about before. But why don't you take it away, Julie?
Sure. So we're going back not too far in the past to 2007. So at the 38th Lunar and Planetary Science Conference, which was held between March 12th and March 16th of 2007, it was announced that the NASA Cassini probe had found evidence for seas filled with liquid hydrocarbons at high northern latitudes of Titan. The seas were detected via radar and were much larger than the lakes that had been detected at that point, the largest being about 100,000 square kilometers in area, which is larger than Lake Superior. And it covers at least 0.12% of Titan's surface. In comparison, the Black Sea covers about 0.085% of Earth's surface. So given that ratio, they went with seas to describe these areas. The areas in question appear dark, smooth, and irregularly shaped in the radar images, which led the researchers to conclude that they were liquid, likely methane and ethane, given the conditions on Titan and the composition of its atmosphere. Carl Sagan had hypothesized that Titan must be covered in oceans to replenish the atmosphere. However, the Cassini probe, when it arrived, revealed that things were chaotic and geologically active, and there were no large surface oceans. But the probe, as I just mentioned, found these lake-like features and above 65 degrees of latitude. Though, the lake and sea features are very much to the north of the moon, there are river-like channels all over the moon. So every time we go with something sophisticated, we find out more things.
Yeah, and of course, our dream of sailboating on Titan is not yet dashed, and that's the important thing.
Yes. Although I'm not sure that I would want to be on that boat. Might be a little stinky.
Yeah, not without some sort of protective spacesuit.
Very protective safe.
Yes.
I mean, a quick dip in the lake there at minus 180 Celsius, give or take, definitely a touch chilly for my plans.
Yeah. I'm not going for a dip either.
The science fiction writers have us covered there. All we have to do is evolve our biochemistry to survive the low temperatures.
Not likely in my lifetime, I'm afraid, but you know,
No,
anything
no.
is possible.
Uh,
The only other
but yes,
object in the only other object in our solar system, though, that actually has liquid on its surface. Many others, of course, we believe have liquid beneath the surface, but Earth and Titan, the only two places where liquid routinely survives on the surface.
yeah, and of course, we haven't talked about this yet, but Titan's great similarity to early Earth, or what we think early Earth might have been like, is one of the things that makes it so interesting. And just the potential biochemistry in these oceans of Titan is something that makes a lot of people very, very interested to go and explore.
Earth in a deep freeze is, I think, the way Carl Sagan initially described Titan back in the 70s as he pushed hard for a Voyager flyby of Titan. In fact, the Voyager 1 flew sufficiently close to Titan that it sacrificed the rest of the tour of the solar system, Uranus and Neptune and potentially Pluto, by making sure that they got up close and personal with Titan, only to find, of course, the atmosphere was completely sort of hazed with tholins and so on. It was a bit of a disappointment in that regard, but it gave us our first tantalizing hints of the chemistry and potentially the biochemistry associated with this satellite.
Worth
Yeah,
it.
and actually the atmosphere is has some really wonderful I suppose audio effects as well, because they did release, and this is obviously a bit later, after the Cassini missions, they did release a recording of the winds of Titan, and you can play that back. I was hoping to get it to play back over this audio, but it's not quite working. So I highly recommend people to check that one out as well.
Julie, were you about to say something? I sort of cut you
I
off, and I'm
just said it
sorry.
was, that's all right. I was thinking it was worth it to get that close
Yes,
to
correct.
Titan.
Back in the late 1970s. I mean, the Voyager probes, both Voyager 1 and 2, gave us a lot of really great insights into the Saturnian system, including, of course, Titan. And Pioneer 11 was the only other spacecraft that visited there before this century and the exploits of Cassini.
Yeah, exactly. As I totally agree with you, Julie. It's always worthwhile to try to explore something new that's never been seen before. And Saturn is often sort of referred to as the jewel of the solar system. Why would you not want to go and explore its most interesting moon, or at least the most interesting moon so far?
Yeah, agreed. I mean, now we need
There
to
is,
get some.
sorry,
No, go ahead. Go ahead, Paul.
there is kind of an interesting story about the Voyager spacecraft. That when they sent them out, there was originally an idea to do a grand tour of sort of the outer planets, just because of um, an alignment that was going to be possible to send a spacecraft from one to the next to the next. And when I think it was Voyager 2, no, it might have been Voyager 1, got to Saturn, they had an option to send it on to Pluto. But if they did that, they couldn't do a close flyby of Titan. And Carl Sagan pushed for the close flyby. And of course, the instruments on the Voyager spacecraft were not optimized in any way for looking at Titan. So all they saw was an orange ball. But that was enough, because there was obviously thick atmosphere and a few other things to help justify the Cassini spacecraft years later.
See, totally worth it.
Exactly. And of course, we have lots and lots of fun, reasons to go back to Saturn as well. So Julie, do you feel up for a riddle?
Yes, always.
All right, and anyone who is playing along, please feel free to tell us in chat on YouTube or just say hi. All right, so this is the next one. And it's not directly related to your story. This is an interesting feature that's not to see between Saturn's ring A and B. Mimas is there pulling a path that's free. It was discovered by a fellow named
Cassini.
Cassini. Yeah,
It's the
you
Cassini
got it.
division.
Exactly. So I thought that would be a good crossover with your story. And of course, we talk about Cassini a lot, and we have to make sure we're clear whether we're talking about the spacecraft
Or
or
the
the human
astronomer.
person. Exactly. Um, but this was the human astronomer who discovered. And it is
Yes.
something that you can just spot if you happen to have a large enough telescope,
Mhm.
because it's a fairly substantial gap in the rings. And I
Yes.
believe our 1 meter image, which was reduced by observatory member Zach, did show up on the viewing for OPV earlier, that just about has the Cassini division visible. Have you managed to tease it out, Julie?
I am not the best of astrophotographers. Uh, so not photographically. Um, I feel like at some point, like I can remember Monica, who worked at the observatory at the same time as me, going, "It's so clear tonight. We can even see the Cassini division."
Oh,
Like
well.
like that's a thing that stands out in my head.
Yeah.
I don't know if I'm making it up, but
No,
like
you're
it,
not. I remember the two of you, you were very excited. You were using the 40 centimeter telescope when you saw the Cassini division. So this was, back in the early days of the 40 centimeter when its optics were nice and crisp and clean and so on. And it was residing in the dome where the 1 meter is now. But yes, the Cassini division has been spied by many of the observatory team over the years. And you're not making it up, Julie. You and
all
Monica did
right.
see it.
It's like core memory.
Yes, exactly. It's very neat. It's very nice, but you do have to have good seeing. And in Toronto, that sometimes is a bit of a challenge.
Yes, and I would say probably more so now that we have the football stadium lights to deal with at the observatory. You need clear seeing, good skies, and of course, no football games. Um, but if folks are trying to view the Cassini division, getting out to something like a dark sky preserve can help a lot if you've got a smaller telescope. Um, do you know, Paul, what's the smallest telescope you've been able to see on a clear night the Cassini division with?
That I would absolutely be convinced I saw it an 8 inch. I don't believe I've seen it with anything less than an 8 inch. And I've looked, but between seeing and so on, it just didn't come up. But an 8 inch is the smallest that I've seen. Jim Laframboise, one of the emeritus professors from York, uh, often travel out to my backyard because it was out in the middle of nowhere, and he would look at Saturn, and there it was clear as day, nice clear sight, a nice 8 inch. It was a Mead Schmidt Cass 8 inch, and no question it was there.
Oh, excellent. Yeah, so that's actually better than what I was thinking, because I've seen it on the 14 inch out at Killarney Provincial Park. And I was like, oh, this is a pretty small telescope to be seeing the Cassini division with. But it is a very, very dark sky sight. So it's nice to know that we can go down to 8 inches telescope size and still see it. But it's not something that folks with binoculars should expect to see. Most of everyone who's looking at Saturn just casually with a small telescope or binoculars, you'll get the usual view of the Saturn and the ring, except for the next couple months or so, where when it does come back out from the other side of the sun, we're still going to have that very, very thin ring for a while until the tilt comes back.
It's the sort of thing that you just need to keep observing. You'll go to see it in this thin configuration as you just described, and then over the coming years, you're going to see that tilt expand. And it's really nice to have that local memory of Saturn as it changes. So do keep an eye on
Yeah.
it.
Oh, absolutely. I always like to say there's always a good reason to go look uppity, and Saturn is going to just be that good reason forever, probably. So if you have Saturn up, just take a look. And even if you just have small binoculars, you'll still be able to get that real view of the very, very thin rings slowly becoming bigger as we go, out of March into April, June, July, and over the next year. And of course, if you've got a bigger telescope, you can try for the Cassini division. Optionally try for the Cassini division.
Well, that's
All
why
right, so
people
we
should come out on Wednesday nights to visit you for public viewing.
absolutely, and that does remind me, we do have a couple reminders today to do as extra items. And we are about halfway through the episode. So I just would like to go ahead and also remind everyone that you are, in fact, listening to York Universe. We're broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Our website is at yorku.ca/science/observatory. If you want to ask any questions or if you've missed the chat and want to send us a message, you can always find us at observe@yorku.ca as for email. And of course, for the online public viewing live broadcast part of the show, you can look for OPV or online public viewing or any of our YouTube links over on that same website, yorku.ca/science/observatory. So this is our 600th episode, the Saturn Spectacular, and we're just talking about, I guess, all things Saturn and its rings. And of course, as we approach the ring plane crossing on the 23rd of March, 2025, um, Saturn's rings will appear to be totally edge on. At that time, on the 23rd, it is going to be very uncomfortably close to the sun, unfortunately. So if you have a chance, just as the sun's setting, if it's totally safe and you're definitely not looking at the sun, you might be able to catch it. It's really, really close at the moment. You need a very, very good view towards the horizon. Now we have lots of fun things happening in this episode so far. A couple little news items. Now we do have um, couple things happening at the observatory that I probably should tell everyone about. First of all, Saturn. This is the week of Saturn exploration, actually. So we're not just doing a Saturn-themed 600th episode. This coming Sunday, March 9th, the Allan I. Carswell Observatory crew will be going to Downsview Park in Toronto to the community center, and we'll be doing a live show there all about the rings of Saturn and the ring plane crossing with live viewing afterwards. So we can't bring the 1 meter, it's too heavy. Likewise, the 60 centimeter, but we're going to bring some small telescopes and they are going to turn off all the park lights for us. So we'll get a little bit of a dark sky sight if the skies are clear. So if you would like to join us on the March 9th public viewing event, it is free. It's out at Downsview Park, which has a subway stop attached to it. Just one subway stop down from York University and the Allan Carswell Observatory. So that's happening now. Of course, on the 5th, we'll have our regular Wednesday tour. And if it's clear, you will all be able to see the 1 meter telescope for yourself that you heard the beautiful sounds of earlier, the siren song of the dome rotating around. And of course, we have one more final announcement for the observatory this week. The Astronomer in Residence program is happening again. It's 2025. We're running it again at Killarney Provincial Park in Ontario, Canada. And that means that we have our 10 and 14-inch telescopes on site in the Killarney Provincial Park, which is a well and truly dark sky site. It's actually a dark sky preserve, and we'll be running astronomy programs out there with the observatory telescopes on site, as well as remote live sort of viewing like we do on YouTube. So it's happening again. The applications are open if you know a qualified astronomer who would like to apply. And if you're planning on going camping, I highly recommend checking out one of the live shows that happens all summer with our program. And you can read about the blog and all that stuff on the website I gave you all before. So that's all the news that's fit to print. Saturn is very, very close to the sun at the moment. Paul, what do you think the last chance for views will be?
It might already have passed as far as the evening sky is concerned. I think, as you've indicated, it's uncomfortably close to the sun at this point in time, and I would be very reluctant to recommend people searching the western horizon just for safety concerns. But in a month or so, well, probably 6 weeks, it will pop out in the morning sky and be rising higher and higher in the morning sky. And so for the early risers, that is perhaps the better time for viewing.
Absolutely, I completely agree. Wait until it comes back out the other side, and it's only going to get easier to see.
That's exactly right.
Just whatever you do, as we said during the solar eclipse, don't look directly at the sun. So, as a common viewing errors, the sun, if you try to look at it, it's kind of going to make you want to close your eyes. Go with that because it can really damage your eyes to be looking directly at that high intensity light, and we don't want anyone's eyes to get damaged. We want you all to be able to see the Cassini division, and if you would like to see some pictures of a ring plane crossing, though, I will say that NASA has some excellent ones from previous ring plane crossings. And of course, the Allan Carswell Observatory has been collecting some lovely images of the rings getting very, very thin. So we have some of those up on our website as well. And if anyone has other pictures that they'd like us to share, please go ahead and send those via email.
Just while we're talking about observing on the western horizon, it's not Saturn, but let me digress for just a second. Mercury's best observing opportunity this year is coming up basically this week. And so anybody who has never seen Mercury, you won't be able to see it with a telescope in all likelihood, but binoculars, wait till the sun goes down and then sort of count off about 10, 15 minutes. Venus is high and bright in the western sky. If you find Venus, take your binoculars and then look about halfway between Venus and the horizon, and you will see literally a bright first magnitude point of light, and that is Mercury. So if you've never seen Mercury before, this week is your best opportunity in the evening sky. I mean, there's always an opportunity in the morning sky, but I'm always asleep. But in the evening sky, go find Venus, use that as your starting point halfway between Venus and the western horizon, about 15 minutes after sunset, you'll find Mercury.
Yeah, and if folks have been seeing some of the astronomy news, this is all part of that planetary parade that people were talking about. Gosh, was it last week? I forget. I
The
forget when
last 2
exactly.
months.
Yeah, the last two. It's just well, it's been spectacular. We've had
Yes.
so many great planets to view, and for viewing, Saturn is just too close to the sun right now, but Mercury is amazing. We still have Venus, Jupiter, Mars, the Moon, all easily visible to the naked eye. And if you do have binoculars, you can try to go for Neptune or something.
Well, Uranus maybe. I think even binoculars,
Oh,
you'd be
Neptune, yeah,
very
you're right.
hard
Neptune's a
pressed.
little too close.
Yeah.
Uranus is a better bet for
Mm.
uh, binoculars or strong binoculars, I should say.
Yeah.
Strong
Steady
binoculars, small
hands.
telescope.
Steady hands.
Yeah, it is. There's a reason why it took so long to find it.
Yes. 1781, nearly 180, 170 years after the invention of the telescope.
Yeah, exactly. And we've got a lot of fun planetary stuff happening almost every day, it seems like, between the planet parade and Saturn's rings disappearing. We probably shouldn't forget to remind people that there will actually be a lunar eclipse, a total lunar eclipse, coming out pretty soon as well.
Blood moon, blood moon.
Yes. Yeah, well, and it is going to be unlike the Cassini division. Lunar eclipses tend to be very easy to view because whoever is on the nighttime side of Earth when they happen, if it's a total lunar eclipse and you have any kind of clear skies, you'll probably be able to see the moon turning red. So that's actually coming up March 13th through 14th. So we'll be talking about it a little bit more next broadcast, I think. But just as an FYI, this is a fabulous month for astronomy.
Late evening, is it? I can't remember the actual time. Is it late
Yeah, the
evening?
timing is not great. So you want to go Eastern time. I believe it's around midnight to 2 a.m. or midnight to 4 a.m. I think is what it was, but you guys can correct me in chat. It's not
Sounds
a
about right.
wonderful timing for the East Coast. It's
Hmm.
better
Good for
on the
me.
West Coast. Yeah.
Good for me.
West Coast will have an easier time doing this particular one. Us East Coast folks, we're gonna have to stay up late, but we'll try it.
You just set an alarm.
That's true. That's true. But after something so exciting, how are you going to go back to sleep?
Oh, so easily. I set alarms. I open my eye. I look out the window. Does that look like clear or does it look like clouds? If it's clouds, I roll over, go back to sleep. If it's clear, I go outside for 10 minutes and then go, okay, I've seen it, and go back to bed.
Excellent.
Excellent
Well,
constitution, Julie. Excellent.
and of course, if we're trying to plan lots and lots more viewing, we'll go and get even more Saturn views this coming months. Now we have, I think, a few fun semi-news items. Now there's been a lot of talk about possible upcoming missions, and I noticed that Paul Mackin, you've got a little bit of a crossover with Dragonfly and Saturn, was it?
That's right. Yeah. This past Friday, my brother Scott called me. We're both, photographers and often collaborate. But he just purchased a drone, something I've been considering for a while as well. And he was flying one around one of the many waterfalls near Hamilton, Ontario, which is where he lives. And he sent me some footage. And despite the high winds, the video was amazing. Anyway, this made me think of this ongoing story concerning Saturn. Many people have heard about Ingenuity, the drone that successfully explored a region on Mars with the Perseverance rover. It was originally scheduled to fly 5 missions. It completed 72 flights over a 3-year period and became a bit of a public darling. But that mission also served as a technology demonstration for the upcoming Saturn project by NASA called Dragonfly. It's currently scheduled to launch in 2028 and should arrive in Saturn's moons around 2034. Uh, Dragonfly is an orthocopter, so it's got 8 propellers and it's got a radioisotope or a radiothermal isotope nuclear battery. It's all called an RTG as its primary source of energy. The mission will directly land on Saturn. It'll do, flying through the atmosphere with a heat shield and a parachute, and then the rover will fly off and land. And it will gather data at each site for about 2 weeks before moving on to another site. Its mission is going to be to look for prebiotic organic compounds, and Titan's probably a pretty good candidate for that. It also has cameras and a seismometer and spectrographs. And one of the things that I wonder about with Dragonfly is it, because of Titan's thick atmosphere, will it be able to look up with its camera and image Saturn and the rings, from the surface of Titan? Would be a great picture. So I don't really know the answer to that. I suspect it will be able to, but it sure would be something to image Titan from the surface of Titan, and image Saturn from the surface of Titan, and from there the rings will never vanish, or maybe they will.
Well, they will eventually, actually, which is a good point because we've been talking about how the rings will appear to disappear due to this Saturn ring plane crossing. But we do think that I was reading a little bit about the latest estimates for how long Saturn's expected to have rings. It's going to be a long, long time, but in the distant future, and quite distant, we might actually have enough of the rings degrading, and what we think is happening is something like a ring rain, where the bits of the rings are falling into the planet of Saturn. And this idea has come around a couple times about how the rings might be slowly getting pulled into Saturn. And Cassini, one of the great things it showed us was that Saturn's rings are actually younger than we think. They might have been there just the last 400 million years. So old, but not compared to the 4.5 billion year history of Saturn. So maybe they could be degraded within another 400 million years. So maybe this is just their sort of halfway point. And the latest calculations that I saw from NASA were that the Saturn's rings are actually losing about somewhere around 1,000 pounds of water ice per second. So you get a one Olympic-sized swimming pool of ring ice going away every 30 minutes. It's huge. The rings are massive, so this is not going to make them go away in our lifetimes, but it could be enough to wear Saturn's rings down over time. So they might actually disappear from sight in a real way, but we'll have to stick around as humans for a few more million years to find out.
The age of the ring system has certainly been one of those ongoing debates. Are they very, very old, as in billions of years? Are they relatively young, as in hundreds of millions of years? I think the case for them being more transient was made when we started finding the ring systems around the other Jovian worlds. I mean, there are ring systems now known around Jupiter, Saturn, Uranus, and Neptune. Saturn's is by
Exactly.
far the most well developed, but the sheer fact that all of them have rings does point to a transient nature of this particular phenomena. But how old that transient really is, as you say, Elena, is still an ongoing debate. Maybe it's as young as 400 million years, and that's the halfway point, but that still is relatively long.
Absolutely. And I see that we've actually got one more really fun thing to discuss here. I don't see who put it in. Who was it that on our crew tonight that wanted to talk about Enceladus?
That was me.
That
Sorry,
was
forgot to stick
you.
my name in there.
Well, I'm sorry, I'm probably pronouncing it wrong, but it always makes me think of salads, but it's not. It's a wonderful moon. So tell us more, Julie.
Well, on pronunciation, maybe we need to approach it from. I had a colleague who was a paleontologist, and he had a prof who said, as long as you're not adding or deleting a syllable, then pronunciation doesn't matter.
That's an interesting rule.
Yeah. Okay, so the geysers on Enceladus might not come directly from the oceans. So the
Ooh.
geysers, the geysers were first discovered by the Cassini spacecraft, and they hint at a subsurface ocean, making the moon a candidate for the search of life in the solar system. But there's a new study published in Geophysical Research Letters that was led by Professor Colin R. Meyer of Dartmouth College. And this study suggests that instead of originating from the oceans and just having like a passage from the ocean to the surface, the geysers originate rather from a mushy zone of briny ice within the icy crust. And if this is the case, this would change how habitability of Enceladus is assessed, as well as that of other icy moons. The model put forth by the team proposes that the process that produces the geysers is shear heating, where friction between moving ice layers generates heat that melts pockets of ice in the crust. The motion would be caused by tidal forces from Saturn, causing stress in the shell of ice that's around the moon. And then the brine escaping through the fractures would create the plumes. The study identifies two weaknesses of the previous hypothesis, where the geysers are just directly going from the subsurface ocean through, fissures in the ice to the surface. One is fracture stability. So the previous hypothesis doesn't explain how cracks letting the water escape would stay open, as well as a transport mechanism. There's no explanation of how water rising through the cracks wouldn't freeze and clog them on the way up. Enceladus, despite the study, regardless of which of these two hypotheses turns out to be right, or if it's neither of them, there's some third thing happening, it's still a prime candidate for the search for life somewhere else in our solar system, because Cassini data showed that the plumes contained water vapor, carbon dioxide, methane, ammonia, nitrogen, salts, and silica, all of which are needed for life on Earth. In the new hypothesis, the fractures are an important conduit for life, with the briny pockets of ice in the crust exchanging material with the deeper ocean. So it's kind of like an extra step to the surface.
Wow, that's really cool. And of course, this is a brand new paper. And I saw the old models where they were just like, okay, ocean, ice crust, that must be what it is.
Until we go there or have a more, detailed study, we're not gonna know.
We'll just have to go visit this one too. And it's really interesting because, of course, this is so much smaller than Titan, right? So this is about 1/10 the size of Titan, and that's that's a massive moon, obviously, but this is a fraction of the size, and it's already an interesting location for chemistry and possible life. And I mean, briny ice, that's really interesting.
1/10 the diameter, but only 1/1000th the volume. It's tiny by
Yes.
comparison with Titan.
Yes, I should have said diameter. Yes.
That's okay.
It
I
is.
knew what you meant.
It's tiny, and also very much less mass.
But it does show you've got to go to these places. I mean, one of you said that you can't determine these facts from afar. You can't even guess at these facts from afar. You've got to be there in situ observation. That's why it's so very important to send spacecraft to these worlds, to these objects, to get a better understanding of not only their morphology and their history, but the history and morphology of the solar system.
Yeah, and of course, the more we find out about the strange chemistry of Enceladus and Titan and Saturn itself, the more we kind of learn about, what we think life processes on Earth were, because we still don't exactly know how life landed here originally. There's a lot of debate, and this only helps. And of course, seeing things like giant jets of water shooting out of this tiny little moon. Um, this is just such a wonderful effect. I never would have thought these sort of jets of water shooting out would be happening around Saturn.
3 cheers for tidal action.
Absolutely. Really, really interesting stuff. And unfortunately, like usual, we are running out of time for the episode.
Nothing
So
changes in 600 episodes.
nothing's changed in 600 episodes. We always have more to talk about. Fortunately, we will, of course, be back next week. So Paul Delaney, thank you very much for joining us tonight for the Fabulous 600.
Happy to be here.
And Julie Tomei, thank you for coming back again. It's it's been great to have you here as well.
Thank you.
And we have, of course, Paul Mackin, our new regular. Paul, thanks for coming on.
Always a pleasure.
And Sana, thank you very much for joining us live from the telescopes tonight.
Oh, thanks for having me. It's always fun.
All right, everyone, this was our 600th fabulous episode. We're going to have to stop here, but don't worry, we will be back next week. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been numerous, actually. We've had many, many people on joining us for our 600th episode. I hope you all have really enjoyed it as much as I have. You can always connect with us on Instagram and Facebook and PixelFed, either Yorkview Observatory or Allan I. Carswell Observatory. And you can check out our website for show notes, free tour tickets, content, updates, archival images, and of course, archival episodes of York Universe. Everything all you could ever want astronomy-wise, yorku.ca/science/observatory. Thanks for tuning in to York Universe. Clear skies, everyone, and have a good night.